So, let's start by just seeing if everybody's with me. Would you please turn your iPads my way and see who I am still waiting for. Phones are fine, but go to wait now. Yes, you may. There, you can grab my charger right there and just plug it in. And in the meantime, grab some scratch paper off my desk and just use that. Thank you, everybody. Here we go. So, I'm teaching you something today that is called piecewise functions, and it's because each little piece of this function is completely different. They aren't like all a part of a unified group. They're all like different. There's this part, and there's this part. So that begs the question, what are the rules for a function? You can do that? Yes, you can jump around like that. This function is not what they would call continuous, because a continuous function is a little more graceful. You can just like keep drawing it without ever lifting your pen up. That's called continuous. But not all functions have to be continuous. But a reminder, all functions have to pass the vertical line test. So here's a vertical line, and it's going through and only touching once. This is a place where it went right up to it, but it was not there. An empty hole means that the function didn't touch there, but the hole is kind of saying, but it goes right up to there. Okay? So like at this spot, this is where x is 1, and only one of these three, I like to think of them as like separate countries. I'm going to say there's the green one. Does it own that spot? No, it goes right up to that spot, but doesn't touch that spot. There's all kinds of rules in the real world about borders. One of the things that there is a lot of countries have a border that's on the ocean. Okay, and so up to 2 miles out, it's kind of like your ocean. Okay, buddy, once you go 2 miles out, it's not your ocean anymore. You can't just say, we own that ocean that goes way, way, way out there. No, you got like 2 miles. Now, you can have other rules that go out like 12 miles, but once you get past like 12 miles, then all of a sudden, you don't control that at all. If it's 12 miles off your shore and the U.S. wants to like go park an aircraft carrier out there, we could. And I could have my numbers off a little bit. But there's rules about how close you can be. Well, countries always have troubles on the border. So Pakistan and India, for example, it's like this blue one is Pakistan and this green one is India. They both claim a spot. And there's always trouble if they both claim the spot. They both claim this place called Kashmir. It's the Kashmir region. And they both are nuclear-armed countries, and they both say, that's ours. And they all actually fight over it, and they actually are deaths with their military personnel fighting in that area. So it's obviously a really scary, contentious zone. Minnesota's got a weird one. I just learned the other day that there was a dispute on Lake Superior over who owned the island that's right up there. Does anybody know the name of that island? It's just off the coast in Minnesota, but it's really close to Canada. All right, well, that island up there is actually owned by Michigan. It is like literally just offshore from Minnesota. That's Michigan. I didn't know that, but now I do. And there was an argument for a while that Canada said they owned it, not just like yesterday, but like a long time ago. So they had to like fight it out over like who's going to own that. So anyway, it's part of the U.S. but it's like super way right next to Canada, just offshore. Okay, so the trouble with these in my grading of them is going to be there's going to be tons of kids that are going to make a solid dot here and then a solid dot here, and that can't work. They can't both own that point, or it won't pass what's called the vertical line test. So here's another just reminder on the vertical line test. Here's a function. Does it pass a vertical line test? Yeah, I can draw a vertical line at any point I want, and it only touches once. Whereas if I make this function, that's why you never see like curlicue functions, because it wouldn't pass. If I put in the number x equals 1, this is where 1 is on the x-axis, it would have 3 different outputs. Can't do that. That doesn't pass a vertical line test. It's not a function. It's a thing. There are graphs that do that, but they're not functions. Okay, so these functions that you're studying today are called piecewise functions because a lot of times there will be 3 pieces of the function. Now, this brings up an important point. These have horizontal lines in them. I want to take just a second and say, I know you learned this a long time ago, but this is the x-axis, this is the y-axis, and if I have a line that goes like this at, let's say, y is 3, then that line is called y equals 3. Notice there's no slope. Why is there no slope of the line? Because the slope is like 0.
So then you just multiply x by 0 and then you just get...
Yeah, you could even just say it's 0x plus 3. It's got no slope and it's at a y-intercept of 3. So we just say y equals 3. So remember, a horizontal line is a y equals line. And a vertical line also exists. We aren't going to really talk about it much today because they don't pass the vertical line test. But a vertical line graph like this, that's an x equals. So like, let's say it's here at -4, x equals -4. That's a vertical line. We won't ever do them because they don't pass the vertical line test. All right, so we are going to have these though. So make sure you remember that lines that go across like this are y equals lines. All right, let's go on to the next page. Everybody get to this page. Do you see that this function has 3 parts? I want you to color in this part as black, this part as blue, and leave the last part as green. That way I can talk about it in terms of like the black part of the function, the blue part of the function, and the green part of the function. Do you get, this is a more normal slope. It's got a slope. This one doesn't have a slope, so that's one of those y equals lines. And this one, if you really think about it, if I extended it out, do you get it would just be a parabola? But it's kind of cut off. All right, so this part of the function is a parabola, y equals x squared. The green part of the function is y equals 3, because that's right between 2 and 4, okay? And this black part of the function is y equals, well, I know this is questionable, but if I extend this out, it goes through -2 and it goes through 2, and that means it goes through -1, 1, and I can tell all these points, if I extend that out, that's y equals x plus 2. Process that for a second. Do you get it's got a y-intercept of 2 and a slope of 1. Go over 1, up 1, over 1, up 1. Does that make sense? Okay. Now, why can't I just say that that's my answer? Well, it's kind of right. I mean, if you just kind of want to know what 3 functions are involved, those are the 3 functions, kind of. But if you have to be specific, then you have to say, oh, this is only this when x has to be between -1 and 2. And even more picky, the blue one we're going to say owns this spot. It clearly owns that spot. So it goes right up to 2. But we're going to say that the blue one does not own this point right here. Remember, only one of the functions can own it. We're going to say that the black one owns that spot. So then we would say it owns 2, but it does not. There's no or equals here on the -1. Because this one owns the -1. And this one exists at -1 and everything less than -1. And then the green one, it exists only when x is bigger than 2. Why not bigger than equal to 2? Look, the green one doesn't own the 2. That's why I cannot put an or equals right there. I can't put an or equals there because it doesn't own the 2. This one owns the 2. There's always disputes about border and who owns what. Okay, so now that got kind of messy, and so math, the person who invented these things, decided let's put it all into one function. So they write this, f of x, you don't have to copy this, you can just watch. It is three things. It's this, and it's this, and it's this. So you write those three things. It's 3, and it's x squared, and it's x plus 2. And then, to kind of keep it organized, it's 3 only when x is greater than 2. And it's x squared only when x is between -1 and 2. And it's only this one where x is less than or equal to -1. There is how your problems look. They have one function that has 3 different functions in it, and it's only this function when x is bigger than 2. It's the middle function when x is between -1 and 2, and it's bigger than 2, or sorry, x plus 2 is the function when x is less than -1. All right, I know that's a lot. I warned you, this is not as easy as those other functions were. All right, let's look at this one for a second. Would you agree there are 3 distinct parts? Let's color them in so we can describe them better. Let's call that one black, leave the middle one blue, and let's make the green one on the end here. Do you see how this function has 3 specific parts? Or wait, is there another? I didn't even notice this last hour, but a kid pointed out, what about that spot at 1, -2, Mr. Server? And I was like, I didn't even notice that. There is a 4th function. We're going to make it a red dot. Now, does this thing pass the vertical line test? Because if it fails, I can just be done right now and say, this is not a function. The end. It does pass the vertical line test. Because this one spot where it's kind of sketchy, it doesn't really hit there, and it doesn't really hit there in the empty spot. There's only one place. So it would pass the vertical line, if I draw one in like yellow, it would pass the vertical line test at the only place that I'm worried about. The rest of it, it only touches once, of course, here and here and here. All right, so if I was going to write this function, I would write f of x is 3 things. It's this, which is an upside down parabola. I'm going to remind you that's a -x squared. But wait, the parabola has been moved left and up. We just practiced that enough that you should be able to do this. That parabola has been moved left 2 and up 1. Oh, and it's been flipped because it's upside down. Negative in front. That is the black part. Now the blue part. I did mention it earlier. Who's got a short-term memory? What's the equation for that? Straight across line like that, horizontal line? Y equals 0x because there's no slope. And then what?
X squared.
No, that's not a parabola. 1. Y equals 1. By you answering, that spurred more people to answer, so thank you for trying it. All right, so that's y equals 1. It's a horizontal line at 1, so that's just y equals 1. And this one, you've never learned that function before. So it's just a made-up function. So you'd never be tested on one like that. We wouldn't say, okay, now you got to tell us what that function is. I don't even know what that function is. I have no idea. So I'm going to call it g of x. I'm just going to make up a name. Yes?
Maybe that could be like 2 absolute value functions.
I agree. You're probably right. You could probably blend 2 absolute value functions because see the value, say the V shape kind of in there? Very good point. So there's probably is a function, but we would never ask you to do that. It's way too complicated. All right, I'm just trying to show you that this is made up of 3 separate functions. Do you get that? Now this part you should also be able to do. this part of the function right here, I'm going to highlight it, use my highlighter. This zone, the green function, only exists when x is what? Is it like between two things? Yeah, it's like x is between 1, and it goes over 4, which is kind of annoying. I wish they would have just cut it off right there, and then I could just say it was from 1 to 4. Let's just say it does. Imagine a world where it just ended right there. Because otherwise, what do I do with that? It's like 4 1/4 or something. It goes just a little past 4. So this function only exists between 1 and 4. This function exists between -1 and 1. And wait, it owns one of those two. Which one does it own? -1 or 1? -1. So we say or equal to. And this one only exists. Once again, I need to know if there's an arrow on the end. There is not. So let's just imagine a world where the teacher set it up really beautifully and stopped it right there. Then this function only exists between -4, and the way I did it with a dot there, it owns it. If I wanted it to continue, I'd just say infinity, but and it stops here at -1. Now we said that this function owned the -1, so if I erase this out, you'll be able to see there's an empty spot there. It does not own that spot. It does not own -1, so I could not put an or equal right there. All right, starting to get the idea. Let's see if you get it. Here's a typical problem. On your next test, these piecewise functions are the hardest part of your test. We're going to practice them a bit more. It's not like the test is tomorrow or even the next day. It's a couple days from now. But the hardest part of your test will be this. Now, I encourage you, anytime something is difficult, just do one step at a time. Like if you're trying to write a ridiculously hard paper, you write a page of it. You just write one page. And then just take the next step, which might be like, okay, this paragraph sucks, revise it a little bit. Just one step at a time. So this, don't even worry about that. Just everybody cross that off. We're not going to worry about that part of the function until later. All right. So, can I just graph this everywhere? No, I can only graph it between -2 and 1. So what you're going to do is XY chart. I call it your best friend in graphing. Everybody go make an XY chart. And we will pick those points, -2. And what's between -2 and 1? Well, -2, -1, 0, and 1. Now, we'll find some points that are on this. I know it's an upside down parabola. In fact, I can even kind of sketch that and say, well, I know it generally looks like this, because that's what upside down parabolas kind of look like. But it's going to be limited. It's going to be only between -2 and 1. Now, that's the sloppiest graph in the world, but that's kind of what it's going to look like. If I erase out all the stuff I was kind of cutting off there, that's kind of what it's going to look like. Upside down parabola that only exists between -2 and 1. But you got to be much more careful in precalc than just like that. If that's on your test, I can't give you the credit for it because it doesn't start in exactly the right spot. It doesn't end in exactly the right spot. It doesn't have an empty spot on one end and a solid spot on the other. So let's be a little more careful. When we put the -2 in here, it brings up another important point. Have you learned yet that a variable is an empty parentheses? And that parentheses matters because it'll make us do it in a different order. I'm just writing this with an empty parenthesis where the x was. Now I'm going to stick in a -2. And do you get, if there wasn't a parenthesis there, the two negatives would just cancel each other out. But there is a parenthesis there, which means I'm going to have to go -2 squared and then make that negative. So it would have been positive 4, but then this negative comes in, and the answer is negative 4. And look at my graph, -2, -4. Oh, it actually kind of makes sense. That's where this graph was going. I was off a little bit because, you know, I was doing a rough sketch, but I was pretty close. Now, does it own that spot? Oh, it does not own that spot. Look, because it doesn't say or equal to. So what you do is you circle it and you say not. That means graph it, but go right up to there and then put an empty circle there. Holy cow, there's a lot of little details in math. Some of you are naturally detail-oriented and you're careful, and that'll really help in math class. Others of you are like big picture people, and you get the big idea, but the little details are not so good for you. You're probably the types that will hire an accountant who will keep track of your taxes exactly for you, and you don't have to worry about that stuff. They take care of that. But in this class, you can't have an accountant, so you gotta be really, really careful. So I stick in -2, I get -4, and that's my spot, but I put an empty circle on it because it didn't own that spot. There was no or equals. Now I'm gonna go ask that you stick -1 and 0 and 1 right here in this function and see what you get. Take a second. And we're trying to figure out these little blue question marks right here. What do I get? What do I get? What do I get? And in a moment, when you share this with the kid next to you, you're going to say, like, when I put in -1, I got this. When I put in 0, I got this. When I put in 1, I got that.
Can I?
Pausing. You guys are done, so let's get them out there. If I put -1 into this function, I would get 1 first, and then I put a negative on it, -1. 0 gives me 0, and 1 gives me -1. Double checking that. If I put in a 1 here, it gets squared, and then I put the negative on it. Yep, 1 gives me -1. And if I look at that. It actually matches up with the place I kind of thought it would all be. There we go. That's the first part of my graph. Now, the other part, I can reveal that. Go ahead and unscribble that out. And now it needs its own separate XY chart. But it is not limited. So you could keep going forever, and you'll obviously stop because, you know, you don't want to stay here forever. X is 1, but wait, it doesn't own 1. So you do stick in 1, but you remember by writing a not next to it, which means you need an empty circle. Like this kind, you know? And then we're going to stick in anything bigger than 1, like 2, 3. And I'll tell you, if you have, since these piecewise functions are like multiple functions that have to all get done together, I'm fine with just 3 points. If you graph 3 points on each of them, you'll get the idea if it's a curve or a straight line. Besides, you can just look. If it's got a squared, it's a curve. If it doesn't, that's a straight line. And 3 dots in a straight line, you don't no point in going to 4 or 5 because you can know where direction it's going. All right, so everybody stick in 1, 2, and 3. Remember, it's not there, meaning an empty circle at 1 comma whatever. And you're sticking it in this function this time. All right, would you please again compare with the kid next to you? All right, just check attendance. All right. we stuck in a 1, and we got 3 times 1 is 3 minus 1 is 2. You stuck in a 2, and you get 6 minus 1 is 5. You stuck in a 3, you get 9 minus 1 is 8. So 1 comma 2, over 1 up 2, and that would have been a classic mistake right there. 2 comma 5, 3 comma 8. What? That's what I did. What's wrong? Yes, remember how we said not 1, 2? Which means right there, your graph would have failed the vertical line test. I always say that the problem is always at the borders. The border between the red and blue function and the black one, they both claim to own this. And that would be wrong. I have to minimum take off 5% for that. I'm going to put an empty spot like that. That's perfect. Do you get why it's an empty spot? Because only one of these two can own it. And that function owns the input of x equals 1. The way I know that is I look over here and I see which of these owns 1. No, that one doesn't own 1. Oh, that one owns 1, right? There. You can see that the x squared, the parabola, owns the 1. Okay, I think you're getting the idea. So this is the part where I'm going to give you a worksheet and some time together, and again, a kid next to you you can check with. The worksheet literally has 2 problems, just 2. And let me just show you kind of you'd start. Now we're not doing this one, but I'm just going to say how would I start this? I would look at this, and then the first thing I would do is to try to keep my life simple. I would just not look at that. And I would just look at this, and I'd start by making an XY chart like I do for every graph I ever make. And then I would just pick points like 0, and does it own 0 in this case? Yes, it does. So I don't circle it and say not. This one does own 0, and it's less than 0. So like -1, -2, -3, and I'd make an XY chart for that, and then I'd graph it, and then I would like, okay, now I'm going to focus on this function. And I'd make an XY chart for that. And I'd pick numbers that are bigger than 0, but this time it doesn't own 0. So I go, whatever that is, it goes right up to it, but it does not own that one. Sometimes it's a tree in yours and your neighbor's yard, and you're like trying to decide who owns it. It actually sometimes really matters a lot. I have a tree right now, for example, it's going to cost me thousands and thousands of dollars to take down. If my neighbor owned it, it'd be their problem. They'd have to spend the thousands and thousands of dollars to take the tree down. But it's mine. It's right on the edge, but it's a little more on my side, so dang it. So sometimes in math, the border will look like this. Empty spot here, solid spot here, and then one owns it and one doesn't. All right, so here comes your worksheet. Stop the video for today. That's all I got for instruction. It's a 2-question worksheet.